Hello, this video is to review the radical family, in particular the square root and cube root. What a square root is when you have this symbol like this. So for example, if I took the square root of 25, I'm looking for some number that's the exact same number times itself that gives you 25. So in this case, that would be 5, because 5 times 5 is 25. Another common example is the square root of 81. So if you think about what number times itself that's the same number equals 81, that would be 9. The square root of 36 would be 6, because 6 times 6 is 36. Now, one thing I want to talk about when it comes to square rooting is you cannot square root a negative number in real number sense. So by definition, the square root has to be the exact same number times itself. So if I want to get negative 4, the only way to get that would be negative 2 times positive 2. And those are clearly not the same number. So you would just say it's not possible for real numbers. So later on in high school, when you get into imaginary numbers, you could square root a negative number, but we'll save that for a future discussion. Now, when you do radical square root, you don't always get a perfect square. So my first example would be like the square root of 7. That's not a perfect square. So what I like to start with is to multiply by whole numbers that are close to 7. So for example, if I did 2 squared, or 2 times 2, I would get 4. If I did 3 squared, 3 times 3, I get 9. So obviously 7 is somewhere between 4 and 9. It's a little bit closer to 9. So I want to go a little bit closer to 3. So if it was exactly 2.5 in the center, and I'm leaning a little bit more towards the 3, I might try 2.6 times 2.6 and see how close I get. And when I do 2.6 times 2.6, I get 6.76. Which is a little bit too low. So I'm going to try 2.7 times 2.7. If I do that, I'm going to get 7.29. So this one is about 0.24 away, and this is about 0.29 away. So this one's a little bit closer. So I could then make a next guess somewhere between 2.6 and 2.7. Now I'm a little bit closer to 2.6, so I might try like 2.64 times 2.64. And if I do that, I'm going to get roughly 6.9696, which is really close to 7. So if I had to round this to the nearest 10th place, I would say this is about 2.6. So when you do a non-perfect square root, a number that's not a perfect square, I would suggest you round it to the nearest tenth or even the nearest hundredth, because this number is like pi, where it goes on forever and ever and it never stops or repeats itself. So trying to get just an estimate is usually pretty good. We're going to do another one like this. So if I did the square root of 18, let's say, again, I'm looking for what two whole numbers is this going to be between. So 4 squared is 16, and 5 squared is 25. So 18 is between 16 and 25, and it's a little bit closer to 16 than 25. So I want to choose a number that's closer to 4. So I'm going to try like 4.1 times 4.1. And if I do that on my calculator real quick, I will get 16.81. Now if I do 4.2 times 4.2, I would get 17.64. Again, getting close to 18, but a little bit small. So I'm going to try one more time. 4.3 times 4.3, and I get 18.49. And again, as I look at these, it's going to have to be probably, it's close. This one's 0.36 away from 0.49 away, so it's probably something closer to about 4.2. That would be my approximate answer for the square root of 18. So the next part of radical family I want to talk about is cube roots. So cube root is like square roots, where it has that symbol, but there's a little 3 inside it, which means if I do like the cube root of 8, I'm looking for what number times itself 3 times to give me 8. And the answer for that would be 2, because 2 times 2 times 2 is 8. The cube root of 64, now I'm looking for some number times itself 3 times. Because it's a really small number, you're probably going to choose a number that's definitely less than 10. So what I like to do is I like to try a number that, just to try one out. So if I tried 5 times 5, which is 25, times 5 is 125. So this is definitely less than 5. And this actually ends up being 4. 4 times 4 times 4 is 64. Now another thing that's powerful about cube roots is you can actually do negative numbers. So if I did the cube root of negative 27, this actually is possible. And the answer is going to be negative 3. So to prove that, negative 3 times negative 3 times negative 3, you can see I'm multiplying a negative 3 times, which is always negative. And 3 times 3 is 9 times 3 is 27. So I can get the negative 27. So again, you can do negative cube roots. My last example is what happens if you have a cube root, again, that's not a perfect square or perfect cube. So if I do the cube root of 10, now we just did the cube root of 8 is 2, so this is going to be close to 2, but probably going to be a little bit more than 2, obviously. So if I tried 2.1 times 2.1 times 2.1, I would get about 9.861. If I did 2.2 times 2.2 times 2.2, I would get 10.648. Now, this one is 0.648 above 10, and this one's only about 1.39 away. So this one's actually closer. So I would say that around this to the nearest 10th place, I would say it's probably close to 2.1.